Hi and welcome. Domain Name System or DNS is a hierarchical and distributed naming system for resources hosted on the internet or in a private network. In this video, I will discuss the security of domain name system, including its architecture, its DNS Query resolution process, DNS security extension known as DNSSEC, and various attacks against DNS and its countermeasures. Before moving further, please turn on the subtitles for this video. Now, in order to establish communication with our destination system, the sender system needs the logical and physical addresses of the destination system. But these addresses are very difficult to remember. Therefore, we use naming system provided by the DNS, which is human friendly. Now, this addressing system is based on numbers or hexadecimal values. For example, a MAC address of the destination system, which is a layer 2 address, and layer 2 is the data link layer of OSI model, and this MAC address is a permanent physical address. Moreover, we also need the logical address, that is the IP address of the destination system, which operates at layer 3 of OSI model, that is the network layer. And this is a logical and temporary address of the destination system. Now, address resolution protocol is used to translate the IP address into its MAC address, and reverse ARP is used to translate the MAC address into its IP address. Now, MAC is a permanent and physical address, but some network interface cards or NIC provide the facility to change the MAC address of a system, and once this change is supported by the network interface card, then this change occurs at hardware level, and once this change is supported by the operating system, then this change only happens in the memory of the system. Now, IP address can also change by DHCP server or by the administrator, or an administrator may also statically assign an IP address to a system. Now, this is all for the addressing, but these MAC addresses and the IP addresses are very difficult to remember by a human being. Therefore, we use another layer of naming system which operates at layer 7 of OSI model, that is the application layer. So this domain name system or DNS provides this naming system or the system names which are also logical and temporary as well, like IP addresses. Now, this DNS or domain name system translate the domain names into the IP addresses, and then this Address Resolution Protocol or ARP translate the IP address into the MAC address. Now DNS reverse lookups can be used to carry out a reverse translation of IP addresses into the domain names or fully qualified domain names known as FQDNs. But this is only possible if the pointer record is defined in the resource record, because this pointer record has the linkage between the IP address and the fully qualified domain names. Now this domain name can be changed by the administrator like the IP address. So this DNS is a hierarchical naming system, and for example, this www.google.com is a fully qualified domain name, and it is hierarchical, and it has three parts, that is .com, then Google, and then www. Now the .com in this case is the TLD or top level domain, and there are 7 top level domains like .com, .org, .edu, .mil, .gov, .net, and .int. Now this .int has been replaced by 2 letters of country code, for example .us. Now there are also newer top level domains which are mentioned over here. Now the second part, that is the middle part, is the Google, which is the registered domain, which one has to register with a domain registrar. And the third part is www, which is a subdomain or can be a host name. So this can be a multi-section subdomain, for example server1 group3 building5 mycompany.com. Now this fully qualified domain name can have maximum of 253 characters, and each section which is separated by .com can have maximum of 63 characters, and these characters include letters, numbers, and hyphens. Now the zone file contains the resource record of a domain, and the primary authoritative name server contains this zone file and manages this zone file for a particular domain, and the secondary authoritative name server has also access to this zone file, but this access is read-only. Now once we talk about DNS query resolution process, so earlier we used the host file which were static and not scalable, but now the dynamic DNS query resolution has replaced this host file process, and this is done on runtime to find the IP address against a fully qualified domain name. So first of all, we perform the lookup in the local cache on the system, which comprises of host file and the DNS responses of the current session. So if the IP address of the fully qualified domain name is found in the local cache, then that system is approached based upon its IP address. But if this is not the case, then this dynamic DNS query is performed by the client to the DNS server, and this DNS server is configured in the IP configuration of the DNS client, and this DNS query is performed using UDP port 53. Now the zone file transfer is performed between the DNS servers, and this zone file contains the record of a particular domain, and this zone file is very sensitive, and therefore it is performed using TCP port 53. Moreover, TCP port 53 can also be used if the responses to normal DNS queries exceed 512 bytes. Now the DNS SEC or the DNS security extension provides authentication of DNS responses by digitally signing these DNS responses. Therefore, it counters the false DNS responses or the name server abuses. But this DNSSEC does not provide confidentiality. It only provides authentication and integrity of DNS data. Now there are certain attacks against DNS, and the main attack is the DNS poisoning, that you poison or corrupt the DNS data by either attacking the DNS server or its zone file, or by performing man in the middle and other mechanisms and techniques. So one technique is that you corrupt the zone file of a DNS server for a particular domain, and then this name server sends the false responses to the client, and then the client is redirected to the false IP address or the false server. Now this DNS poisoning can also be performed by setting up a rogue DNS server, and this is also known as DNS Pharming or DNS Spoofing, because you are spoofing a legitimate DNS server. So the rogue DNS server sends the false IP before the response from the real server is sent. So this false response contains the same Curie ID or the same transaction ID which was earlier initiated by the DNS client, which is seeking the IP address of a fully qualified domain name. So after receiving the false reply, the client closes the DNS query session, and if it later on receives the real response, then this real response is dropped because there is no active session. Now this DNS Pharming actually set up a malicious website, and the user is redirected to this malicious website. So this malicious website may be set up for targeted users, for example a specific company. Now in 2008, a vulnerability was shown in or demonstrated by a security researcher known as Dan Kaminsky, and this vulnerability is also known as Dan Kaminsky vulnerability. And he demonstrated this vulnerability in 2008 in Black Hat conference. So this vulnerability targeted the name server of a particular domain by poisoning its cache. So this name server is also known as recursive name server, because this recursive name server does not have the IP address of the destination system which is asked by its client. Therefore it send this query to another name server. So by corrupting the cache of this recursive name server, this recursive name server redirects the user to a wrong IP address. So what happens that it actually targeted the cache of this recursive name server by injecting the false information about the authoritative name server of a particular domain. So if a client asks the recursive name server for a particular website which is not in the domain of this recursive name server, and for which it has to ask another name server, then it asks the wrong authoritative name server, since the cache of the name server or the recursive name server is corrupted with the false IP of the authoritative name server of another domain. So due to this vulnerability, the recursive name server each time approach the wrong or the malicious name server for asking resources related to a particular domain. Now another attack is by corrupting the host file of the client. So this client is then redirected to the false IP or to a malicious website. And another attack is by corrupting the IP configuration for the name server of a client for redirecting it to false DNS server. And another attack is by corrupting the web browser of the client so that it is redirected to rogue proxy server, and this proxy server will redirect it to a malicious phishing website. And another attack is by hijacking the domain name or the domain of a particular domain by changing the registration of a legitimate domain, and this can be performed by using cross-site request forgery to steal the current session and then changing the registration of a particular domain. Or it can also be performed by exploiting the vulnerability in a registrar naming system. Now another attack, which is actually not an attack and it is not an unlawful activity, is that once a domain registration is expired for a particular domain, then a third party hires or gets this registration. So this is not unlawful, but it is unethical, but since it is performed or it is possible due to the oversight by the real owner, therefore it is not unlawful. But the after getting the registration for the targeted domain, the third party may set up the same website by faking the clients and targeting the clients for the real website. Now, what are the countermeasures? Now, basically, there are two countermeasures or the two categories of countermeasures. And first category is by limiting the DNS queries and zone file transfer. And second category is by deploying NIDS, which is network-based intrusion detection system, to detect any malicious DNS traffic, and by deploying DNS security extension, and by hardening the client and server. So once we talk about limiting the DNS queries and the zone file transfer, then it is possible by blocking the inbound TCP port 53, that is by blocking the zone file request from external systems which are requesting the zone file for your domain, and also by blocking the outbound UDP 53, which is used to query the domains from external servers, and also by blocking the inbound responses from external servers, so that the malicious servers or cannot send the malicious DNS responses for wrong information. And also by allowing the outbound TCP 53 to limited external servers, that is for zone file request to limited and trusted external servers. So this was all. Before finishing this video, these are the list of resource records which are found in a zone file. So on the left side you can see the names of these records, and on the right side you can see what information each resource record category contains. So this addressing record or single A links the fully qualified domain name to an IPv4 address which is 32-bit, and this second addressing record links the fully qualified domain name to IPv6 address, that is 128-bit address, and then this pointer record links the IP address to its fully qualified domain name, and it is used for reverse lookups of DNS. And this canonical name links the aliases of a particular fully qualified domain name, and this MX is the mail exchange IP related to a fully qualified domain name, and this NS is the IP address of the authoritative name server. And in Dan's Kaminsky attack, this authoritative name server IP was replaced with a malicious or fake IP of a malicious name server of a particular domain. And this start of authority record contains the information about a zone file. So this was all from my side. Please stay connected to my channel for similar videos. Thank you.